Yo! What's up, everyone? Bytor here, following up on that promise of bringing you an OpAmp related question this week. Before we jump into the content, the team and I wanted to say over 1,000 thank yous to each and every one of you for supporting us and making this channel grow. We honestly thought it would take much longer to reach this goal than it did, and we did it thanks to you. Please do keep suggesting this resource and the community to your friends, family, and colleagues. We have received a lot of emails with greetings, questions, and requests. Thank you. Do keep them coming. We are thrilled to know you find us helpful. Don't you think for a second we have forgotten about our promise to raffle interviews with industry experts for our 1,000 subscriber milestone. We are in the midst of planning it, and we'll have more details for you in the coming weeks. This raffle will be open to community members only, meaning subscribers to the channel and LinkedIn. Anyway, let's move on with this week's question. I gotta be honest, this question will trick young engineers as much as the one we published a few weeks ago. You will be able to click on that video on the top left corner right about now. This question should not trick you if you know how to analyze circuits. It will only trick you if you memorize structures without understanding them. So the interviewer will start by asking you to draw a non-inverting amplifier, to which you will draw the following structure. Pretty basic stuff so far. The interviewer might now ask you to write the transfer function for this configuration. Again, pretty basic stuff so far. 1 plus R2 over R1. Now, the interviewer will say the following. What happens if we invert the plus and minus terminals of the OpAmp? So something like this. Following tradition, I'm gonna give you about 10 seconds for you to pause this video and come up with the answer on your own. Alright, so this looks a bit interesting, right? Especially if you're interviewing and someone is staring at you. In this situation, you will either know the answer or you won't. If you know the answer, the interviewer has not gotten any information about you in terms of your problem-solving skills. They'll probably just think that you memorized the structure. If you don't know the answer or don't have it memorized and work your way through it, then you get the points for the question. So a little hint for our experienced engineers. Sometimes it's best to work through a problem the interviewer gives you, even if you already know the answer to it. That is because we are trying to show our problem-solving skills. Who knows, the interviewer might have a twist planned during the middle of your explanation. Anyway, back to the interview. Our best bet is to analyze the circuit like we analyze any OpAmp circuit. That is, KCL. So you can start your answer with something like, well, if we flip the polarities of the amplifier, it is not in negative feedback anymore. It actually went into positive feedback. If I remove the resistors for a second to make my life easier, this is just a plain comparator. Let me pause here and show you the power of simplifying the problem in front of you. We know we are after a transfer function, but by taking this little extra side step, we are showing the interviewer how we dissect the problem. We look for familiar structures, basic structures to ground our analysis and move forward. We are basically showing the interviewer that we are not guessing, but we are rooting ourselves first in something that we have knowledge on. Let's redraw the circuit with the resistors and the flipped inputs. Now, let's tell the interviewer what our plan of attack is. In this case, you can say something like, the transfer function is nothing more than what V out I would get for a given V in. If I start with nodal analysis, I am going to need extra information. So let me call this node right here X. The other input is V in, but since we are not in negative feedback, we cannot assume that Vx equals V in. For now, let me continue to call it Vx and move forward. If I assume the flow of current to be the following, then the sum of currents entering and leaving node X should be equal to 0. From that, we get Vx minus 0 divided by R1 is equal to Vout minus Vx divided by R2. Rearranging all of that, we get the following. Vx equals Vout times R1 divided by R1 plus R2. But wait, didn't we say that a transfer function is Vout over Vin? Here is where we can get a little clever with simplifying and go back to the original drawing of the amplifier without the resistors. If we call this node Vx, then if Vin is higher than Vx, that means Vout is equal to negative VCC. On the other hand, if Vin is lower than Vx, Vout is equal to VCC. So you can tell the interviewer, well, let me take this knowledge to my current equations and write the following. If Vn is greater than Vx, and Vx is VCC times R1 divided by R1 plus R2, that means Vout is equal to negative VCC. If Vn is less than Vx, meaning less than negative VCC times R1 divided by R1 plus R2, then Vout is equal to VCC. This is how we get full points on interviews. However, now that you have this knowledge in mind, let me show you a little shortcut to it. Before we get to that though, please smash that like and subscribe button if you're finding today's content helpful and would like to be considered for our 1,000 subscriber special raffle. More details on this in the coming several weeks. So, we know positive feedback means the output will always be either VCC or negative VCC. Of course, assuming the OpAmp is ideal. Now look at this branch over here. If the output can be either VCC or negative VCC, isn't it this nothing more than a resistor divider? No current can flow to the input of the OpAmp after all. So if we recall the simplified version here, if Vin is greater than the divided version of Vout, we get negative VCC at the output. On the other hand, if Vin is smaller than the divided version of Vout, then we get that the output is equal to VCC. Neat little trick that shows a deeper understanding of the behavior of this configuration. Anyway, that's all I have for you today. I'll be back with everyone next week. Cheers.